Hello everybody, in this video we're going to be having a look at just what is required to get the 0.0 watt power consumption there, and you'll be surprised it's very little that's required, and so how much of this mess is needed you'll probably be interested in. So we're going to have a quick look at that. A quick apology to everyone that's been waiting since my last video where I demonstrated the 0 watt setup, and I've been very busy. That coupled with my normal health issues, I find I run out of energy very quickly, and there's not enough time to be doing extra things and the research. So usually I've got this research going in the background anyway, and that's why everything's sort of on the desk and employed there. But I've been currently learning about AI and implementing AI locally, and it's also helped with doing some calculations. Again, I question the ability of AI to supersede us when we're teaching it, and if what we're teaching it's wrong, it's no different to going through the school. If you learn what they teach in the education department or through the education department, then if that's wrong, then what you're learning is wrong, and how can you be expected to excel beyond the existing boundaries? Anyway, whinge for the day over. So just before I pull all this apart, so I'll pull it all down, and we'll start out with just the bare basics. But I got this 6 watt light here, nice and bright, a bright light warning. I'm going to put you right in the middle of that. I suppose the CMOS sensor did a good job of blocking that. So you can see the CMOS sensor on the camera reins it in. It's bright if it can shine through my fingers like that. That's probably one way to look at it. But for those of you that really need the test, I'll do a couple of videos soon that demonstrate just using a lumens meter how bright those lights are. Another interesting effect I've found is running these lights just in parallel with my circuit, so off the positive and negative after the meter, seems to reduce that 6 watts. I think it was by 50% from memory, so we'll investigate that in a couple of new videos. Like I said, apologies for not getting back to it sooner. I know there are a few of you that are interested in these little things that I have found. Alright, so just before I pull it apart, I'm going to just look over everything so that when I'm putting it back together it's a bit easier. So I'm using this toroid here, and that is what, in my opinion, sets up the resonance, keeps the system in resonance to achieve the 0 watt. If I go without this toroid, so just direct power straight to the circuit, then you don't get that 0.0 watt effect. I've got like a 1-wire setup running from the collector on that green line there, going to capacitor, and then you can see just down in there that capacitor, that full wave bridge rectifier only has one lead. So the other lead there is not currently being used. And so that then feeds into that capacitor, The DC connection for that capacitor is this other green line here, and that goes over to the battery. So again, a lot of this isn't really necessary unless you're doing what I'm doing and experimenting. So when we have a look at the bare basics, we'll get to see whether that's needed or not. And so on top of my coil there with my design, you can check the other videos on my channel. I've got another coil on top, which is a smaller coil. Again, a lot of this is just for experimentation, so whether you want to implement this or not, completely up to you. I've been doing some experiments with this plate here. It's essentially a piece of plastic with 2 aluminium sheets on either side of it. It's very thin. I don't know if you can see with my finger there underneath it. It's not that thick at all, maybe about 6 mil. Anyway, so there's a piece of aluminium on one side, piece of aluminium on the other side, plastic in the middle. That makes a capacitor. So I've got that connected to a full wave bridge rectifier, the other side of which I was doing some experiments off of this toroid and placing, so if I place it on this side of this capacitor arrangement, which is it's sort of like a bifilar coil. Anyway, that's just for experimentation, and so I was doing the one wire through that yellow over to the full wave bridge rectifier, and the other side of that is going to that capacitor plate there. Just to one side of the capacitor plate, got a little piece of paper under the alligator clip to prevent it from contacting the other side of the capacitor plate. Otherwise, it's not necessarily a capacitor if both sides are connected to the same terminal. Then it has less of that capacitive effect. If we remove this green one here that is going to the full wave bridge rectifier and then onto the capacitor and then onto the light and then onto the supply run battery, then we lose our light. We lose the light there, the 6-watt light, and then we're running just my wireless light. It's just sitting in the top there of the second coil that's on top. So that sort of acts like a field extender and extends the field from this bottom coil up into this coil, and then that's being transmitted into my little coil there. If I'm to short this this coil here, which is tricky to do, so then we'll see that it changes the frequency. That little light down there starts to try to work. It increases the wattage, and that's because we've got now a dead short. But if I let that go, my light comes back on. We're now consuming power, and that is because of this yellow line. So if I remove that, this should drop back down. What else have I got there? I've put this green wire. See, that's why so much research has to be done, because you do start to wonder what's going where. Alright, so we've removed that green wire. Now we're down to the 2 watts, and so there's just so many different things you can test. We'll put this green back to run the 6-watt LED, and if you do that without that connection to the negative. So this one here, we'll put that back on there. Because if you try to connect to the collector here, whilst that circuit's running that, it will not only, it changes the resonant field of this one, so this light no longer works. It still emits a field, but it's a different frequency, and that's not tuned to it. So that no longer reads or collects any of the power. We'll put this one back on here, and then we're back to our 0.0 watts. Alright, and the circuit's still running. Alright, and so if we put that back on here, yeah, see, we go back to this 6 watt light, 0.0 watts. So just before I pull all this apart, it's really important to document these things. You know, even if it's just for yourself, you document it, because you will get to a point where you've got spaghetti, and then you start to wonder whether you've done this already or not. And, you know, you'll have a positive result or an interesting result, something that requires a little bit more investigation. And if you haven't documented exactly what it is, you may forget what went where. And so, you know, even if it's, like I said, just a library for yourself initially, that's what a lot of my videos were. I'm going back over videos that I recorded just for me, and so they're not set up in a format for display for everyone else, but I'm going back and then trying to recreate a video from that. So yeah, it's all interesting stuff. Like in the next couple of videos, I'll try and make some more videos. Again, I apologize for taking forever, but try and make some more videos. I'll show you an interesting effect of just running my circuit and running a light like this 6 watt light at the same time off of the same power terminals. And yeah, like I said before, it reduces that to 50%. So all right, one last look at the big mess. I've got like I said, this yellow lead here, when that's connecting these capacitors over here. If I put that back on, okay, so that runs over to that capacitor, again, full wave bridge rectifier connected to the capacitive plate, and then that capacitor connects into that capacitor, or that bank of capacitors, giving it around about, I think it's 13.75 volts DC. I think it ends up at about 100 farad. Yeah, because they're like, what are they? They're 500. Yes, it's 5, so 100 farad. And so then that dumps, if there is any excess power, into the drive battery. And it just makes it run for a very, very long time, even if you can't get it to that 0.0 watt stage. I'll show you with these future experiments that you can at least reduce the wattage of this by half just by connecting it in parallel with my circuit. So all right, one last look, and okay, welcome back. Believe it or not, that took me a couple of days, not because it was a lot to undo, just because I am currently preoccupied with learning about AI, and when I get involved in something, I get probably obsessed is probably a good word, and my sleep starts to suffer because I'm just so heavily invested in learning, and I just have this constant feeling if I go to bed I'm going to miss out learning something. So, which is ironic. If I went to bed, I'd probably have a better sleep and learn more when I woke up. But such is life. So all we've got left is the battery, the solar controller, which then feeds the meter, and then onto the toroid, and that continues on that red line there, and that goes to the collector of my circuit, and that's as bad as clean and as efficient as I could make that circuit. Just put it on one of these terminal strips, because it makes it a lot easier if, when I'm experimenting the 2N305 transistor down in there, if it ever has a problem. It's very, very easy and very, very quick to remove. We've got some little radiant energy collectors sitting there that I just use to see how far the field's going. This current setup has no earth connections. They have a very different effect on the circuit, and I prefer to use them, but this is to demonstrate the bare basics of what's required to have my circuit running. So here we've got my little coils that we've seen, that you've probably seen in other videos of mine. If you haven't, please check out my other videos. Unfortunately, I was recently accused of copying stuff. I don't want to make it into a big issue, but as I expressed to the person that accused me of copying, it's like, well, and I was accused of copying them, obviously, and the person believed that I'd copied everything from them, and it's just, as I had to point out to them, this is Tesla's work, and Don Smith's shown this work, and lots of people have shown this work, and the person was sort of giving me the impression that I needed to get approval from them or give thanks to them, or and I do respect the person who made the accusation, admittedly a little less now, because just kept repeating the same thing, that it would have been nice to give credit. Well, yeah, it would have been if that's where I had have learned it, and where I learned about this stuff was Tesla, talking about the secondary and tertiary coils not actually consuming power if set up the correct way. That was done with just basic Tesla coils. And then Don Smith also demonstrated similar things. The claim was that my coils are a copy. They're not. My coils are tuned to be resonant with my circuit, which is my design. But again, how much can you claim is your design? It has a bifilar primary. Tesla invented the bifilar. Should I not use it ever because someone else come up with it? Should I pay homage to I think my whole channel is paying homage to Tesla. So, look, like I said, I respect the person that made the claim, a little less now, for not being able, as I expressed to them, you should I don't even know why you're asking this question. You know that your work is Tesla's work. And just because I'm showing people how to do this without charging them anything, like this coil, in reality, people are selling these for a lot of money, and materials probably $4, $5. Bit of PVC pipe, a little bit of wire. Obviously, you buy the whole reel of wire, and you get an even cheaper coil. But it's like 54 turns from memory. The capacitor was decided on by trialing different values of capacitor. This person claimed that my coil is identical to theirs, and I'm like, yeah, but if I'm trying to make a Tesla coil and the Tesla coil parameters state that they are certain numbers and certain calculations, and I deviate from that and make something different to that, then I've made something different to that and not a bloody Tesla coil, and that was my initial intention in the first place, is to make a bloody replica of a Tesla coil. So what the actual F? Right, rant over. So we have here my coil, as stated before, and this is one of the things that I like about my coil, is the lack of need for these special ferrite rods and that sort of thing. Yes, I do have ferrite rods, because a good experimenter will see just how important these things are. When claims are made that you cannot do without, usually most people buy something similar or as close as they can afford to get, and they try to replicate, and then they might find out along the way not actually needed. So there's no core inside there. My circuit is just an air core. Okay, and the bottom of that there is the opposite side of a light fixture. There we go. I'll put a 240 volt LED light in there and make that operate. Again, no earths are required. That's the hot line there. Just open to air. So Tesla coil. That's how that works. Okay, so we're not going to get back on that tangent. So my circuit doesn't require those. If we want to use ferrite rods, like, it'll be a bit brighter, a lot brighter actually. So you can see the difference that makes. Don't have to be a rocket scientist. But if you can't afford the ferrite rod, and they're only cheap, you can get different types, specialist types, and all this sort of thing. And that might give you an enhancement in performance. But is any of that necessary if you're pulling 0 bloody watts in the first place? So I don't know. So all I'm doing to achieve that is using this toroid. It has 6 turns on it. So this would be, whilst I just finished saying you don't need special stuff. If you want to get that 0 watt and, a replica of my system, you build something different to this and try and implement this. It may or may not work. That's like trying to take a gearbox for a motorbike and fit it to a car. Good luck. Build it identical to what that thing is, and you'll get that. It's not like you have to buy a special unicorn glitter shit to make it work. People just need to actually put things together and go, oh, what if What if this? What if that? So we can see there 0 watts. If I now take that and place that directly on the positive line for the DC, we get a much higher current draw. It would be good if you could get your act together, mate. So we have a much higher current draw, 5.5 watts. We have a much brighter light, a much larger field that light will work under. It is definitely more intense, and then because we're drawing more current through the negative line here, this small LED is being powered up as well. It's just on one of those little ferrite beads with X amount of wire, maybe 10 turns on that one. Again, nothing difficult, but you know, that's if you want to run a lot of you want to run the extra power through that circuit. If you want to go just the bare basics, this lead here goes back on the start of the toroid, and there we can see, like, after that's on there, I had to move that back into the center because that field is diminished. We've got the 0.0 watts again. This LED is no longer being powered because there's insufficient current flowing in that negative line. So that's about it, guys. Thanks for watching. I apologize for the huge delay in videos. I'll try and get my act together. But ironically, my New Year's resolution was to get busy earlier in the year, and maybe it's just my defiant nature with authority. I won't even listen to my own commands. So, yeah, thanks for watching. Please like, share, and subscribe. I will make some more videos on some other things too, on my magnet motors. And we're going to show a heap of things this year, hopefully. Alright, thanks again. Have a nice day.